Alright, game designers. Class is in fucking session. And, we got a lot of ground to cover, so strap in. First things first, I gotta turn back the clock a little bit.
Go! Time warp!
Let me take you back to 2013. I was still in high school, just a wee little baby shit that didn't know nothing about making anything. But I wanted to make games, and I just found out about a little piece of magic called Unity 3D. Now, keep in mind, back in 2013, Unity sucked. But you can still make ass games with it, no problem. And that's what I did, because I wanted to make games. So I found this really dumb free horse model on the asset store, and I was like, fuck it. I'm gonna make a game about horses, and everything in it is gonna be this dumb fucking horse. So I made the absolute most crackhead stupid game you could ever possibly witness. I consider it to be my first game. And my magnum opus. Now, back then I cannot stress enough, I did not know programming. I did not know code. I was not yet a computer scientist. All I could do was copy and paste random code snippets from tutorials, modify it slightly for what I wanted to do, and pray to God that it worked. It's a disgusting amalgamation of C# and JavaScript, and it's a miracle the damn thing even compiled. But if you want to play this disorienting sensory onslaught, you can. There's a build of it from 2015 on my itch, and it's the last state the game ever got to when I decided I was done working on it forever. But I learned a lot from this. Now I held the key to the castle. My childhood dream of finding out how in the fuck video games get made had been accomplished. And now I can make anything. But before I could do that, I needed to get good. Fast forward.
Time warp!
It's the year 2020. I've been grinding, making games for fun, going to school for computer science, learning how to make the computer bend to my will. The world is changing really fast. And there's a game jam. My friends who like to make games recruit me to help them out. And they introduced me to the new hotness on the street. This shit is some open source wizard fuckery. It's called Godot, and it's free, and it's good. But I had no idea how to use it, so the game we made sucked. But I was intrigued. This engine was so sleek and lightweight, and for the first time I felt like I had a game development tool that gave me all the tools I needed without having any bullshit in my way. I wanted to get better. I wanted to master Godot, and I remembered my past, my origins. I remembered Horse Game, how Horse Game was my way of learning Unity, so I thought this is the perfect opportunity. I had long since joked about making a sequel to the generation-defining work that I had used to learn Unity. Now I could learn this new engine inside out, and to do it I would make the sequel, Horse Game 2. Only this time things would be different. Now I had a bachelor's degree. Now I was a computer fucking scientist. I wasn't some little baby shit that had no brains and no clue. I was smart, and my brain was fucking huge. Now I could make a game! And so I did. And so began the work. So, Godot is amazing, but it's far from perfect. Even today as I'm making this video in 2023, there's a lot still being worked out. But especially back in those days, Godot was looking rough.
God, sometimes Godot just fucking pisses me off, man.
There was a lot of issues and gaps you had to overcome if you were going to put together something good. And I had a lot of plans for Horse Game 2. A lot of standout features that would make the game an impressive and flashy experience. I also had a lot of really stupid ideas about how to structure the game's underlying systems that, at the time, I thought were really clever. They weren't. A lot of the foundational systems were designed in ways that ended up causing a lot of headaches and problems for me down the line. Starting with something I'd like to call dynamically rendered procedural world instantiation. Also, this is the start of Chapter 2, Blunders. I'm using procedural in this sense to describe world rendering, not world generation, which at one point I did actually implement an infinite procedural world generation. I ended up throwing this away because for the type of game I was trying to make and the way I was using it, it really did not fit. Anyway, the idea was based off of LOD, which stands for level of detail. It's a standard practice in which games throttle the amount of detail given to rendered objects based on proximity in order to save on performance costs. Close up, stuff is rendered in full detail, while stuff further away is reduced or even not rendered. But rather than try and implement this, I thought, why even have stuff far away in memory at all? I want to only load in the immediate area and have transitions between areas. You mean like levels? No, not like levels. What I'm talking about is much, much dumber. I would have scenes that would be an area containing everything necessary for that part of the game. Models, collisions, events, interactables, effects, etc. And when I want to go to the next, I could have some event trigger to load in the next area. And when the player crossed over, I could have another event deload the previous area. At first this was pretty cool. I could do these wacky transitions, sometimes seamless, and other times flashy when changing levels. there were problems. Firstly, unloading a level from memory will cause the stack frame to halt while the memory is freed. For individual nodes, this is practically unnoticeable. When you do this for massive packed scenes with hundreds or thousands of nodes, yeah, it starts to become noticeable, even with the shitty, low-res, low-poly graphics I was using. Back in, the Stone Ages, there was a game called Elder Scrolls IV Oblivion, and in that game it would simply flash a quick loading message on the screen when it needed to halt to load in a whole bunch of stuff if you wandered into an area that wasn't yet rendered. It would only be for a second at most, so if that were the end of it, I could have kept going on like this. But the problem is that this version of Godot implemented the GLES3 renderer, which needs to halt the stack frame in order to compile the shaders before continuing. Newer versions of Godot have fixed this, especially Godot 4, which implements the Vulkan renderer. Normally, this problem doesn't exist, but because my scenes had a lot of shaders that were moving in and out of memory all the time, they would all need to be recompiled, which would bring frame rates down so low they made PowerPoint slideshows look like Daytona. The workaround would have been to have a scene loaded at the beginning of the game that stays loaded and has a mesh with all the shaders your game uses applied to it. That way the shaders are already compiled and would stay in memory even if other scenes or other nodes that were using them were moving in and out of memory, because they'd be referencing the same shader that stays in memory. And had I known that at the beginning, I could have organized my files and use of materials in a way that would make that a non-issue. But having worked on the game for a year at this point, who knows how many unique duplicates of materials and shaders are out in random scene files and applied to random nodes. So even if I could, get this process working, I don't know if it would even work. Reorganizing and testing this part alone would be a Sisyphean task. Ultimately, what frustrated me the most is that as I tried to preserve this dynamic area instantiation system, I had to tack on loading procedures to go between and ready the next areas as they grew in complexity. So what was the point? I was building loading screens to help make the thing that was supposed to prevent the need for loading screens. And it didn't even work. What would have been smarter would instead to have been just designing a level as a scene. Each level with a copy of the player that loads in whatever data I need to in order for it to look like it's continuing from the previous scene or the previous game session. Ah, what beautiful lessons we learn and how great our next children become. But more on that later. Blunder 2. Resource-based inventory. The first horse game had flags to indicate whether or not the player had acquired an item. Whatever that system was, I cannot remember how it worked at all, but I can assure you it made no sense.
By my feet!
This time, I would attempt to make a proper inventory system. Spoiler, it would be neither proper nor would it function well. In previous projects, I liked to work with a very simple array of items for the basis of an inventory. Picking up an item simply added that item to the array. An instance of an item would be the same regardless of if it was on the ground, in the inventory, equipped to the player, or displayed in the inventory screen. The item prefabbed in script would have everything it needed to be used and rendered in whatever context it would appear. This only posed a problem once I sought persistence. Godot does not have a very robust save and load pipeline built into itself. Not like Game Maker Studio, which can simply store and resume the state of the game at runtime. You have to design your own save system, how data gets written to a file, what that file is structured like, and how your game parses that information in order to convincingly restore the game to the state it was left at. My lesson to all fledgling game developers: do this first. If you are working on a project, as soon as you have even the tiniest shred of gameplay, if you know your project might someday need persistence, might someday need to have save files, build that system as early as you possibly can before anything else. Having that framework to work off of as you design systems going forward would be so much better and easier than vice versa, as I learned the hard way. Which, by the way, this blunder is also a bit of a twofer because it also includes that additional blunder, which was Blunder 3, not building the saving and loading infrastructure early. When the game had a static state that existed from the start of the game until however long you played, the player and NPCs used a lot of the same underlying code to manage their inventories and choreograph how items kept track of references they needed. I had systems like Interaction Controller and Equipment Manager for handling the ins and outs. Equipment managers had an inventory, an array of items, and could control what was currently equipped, how equipped items handled input and interactions, the whole 9 yards. But the problem with a resource-based or instance-based inventory is that if you want to have a merchant NPC, for example, that sells, wooden planks, then they need to have 100 or 1,000 wooden planks in their inventory. That means instantiating 1,000 instances of that item and adding it to their inventory and keeping those items in memory. I had tricks to be able to do this that it didn't cause much of a performance hit or take up too much memory, as well as ways of holding this off until the particular NPC really needed to have their inventory initialized. But I wanted to achieve that feeling of Oblivion or Skyrim where you could go up to any NPC or container and loot them for any and all items they might have. It just added a feeling of so much depth to those worlds, knowing that every NPC you saw walking around had a full inventory of stuff, including the clothes you saw them wearing, and who knows what else they held onto that you didn't see. This problem became obvious once I was trying to save the game with numerous NPCs. Every NPC in the world with their inventories full, potentially with hundreds or thousands of items. Each item contains so much data being written in order to preserve its exact state. It was an issue of volume. As the number of NPCs and the number of items in the world grew, it quickly reached a point where each save would take noticeably longer to process. The seconds piling up as the mountain of items to iterate through became longer and longer. At first, saving was nearly instantaneous. Loading was the slog, parsing through the data to instantiate the correct world, then iterating through all the nodes of the world to correct their state, deleting nodes which had been removed, instantiating NPCs, instantiating their thousands of items just to place them into their inventory slots. If I saved about halfway through the tutorial, with only 5 NPCs initialized, I could spend 15 seconds waiting for the game to save and up to 5 minutes waiting for the game to load, and not even being able to load correctly. So what did we learn? Well, representation is key. Okay, a little bit of a tangent here. At some point in 2022, I picked up a job working as a game designer for a big company, and I'm really happy about this. I get to work in a game engine every day using my skills and knowledge on creative endeavors and problem solving, working on really crazy and complicated technology. It pays the bills, while also affording me a lot of much needed time to recover from burnout, organize my life, and work on my own projects. But what does this tangent have to do with anything? I'm getting to that. You see, in the work I do, we often don't have the resources or the time necessary to implement fully functional game mechanics in the scenes we build. And most of the time it's really unnecessary given our use case. For all intents and purposes, a lot of the time we're using the games we make to merely give the world's fanciest, most elaborate PowerPoint presentation. Thus, what I've learned here is that when it comes to making games, a lot of the time less is more. If you can fake it, you sometimes get more game than if you tried to do it for real. This has led to a pretty drastic shift in my thinking as a game designer, and although some of the conclusions I've reached may have been obvious to a lot of people, I think I'm figuring out ways of building larger, more complex, interconnected systems that hide the fact that not very much is actually going on, while still managing to convince the player that they are, in fact, playing a game. Getting back on track with what I learned about Horse Game 2, how I should have implemented things is as follows. Defining items as data, purely representationally. I already had files that were necessary for looking up an item by name and finding the path to its associated scene file for instantiation. I should have taken this a step further. This should have been where items were defined, their values, what you can and can't do with them in their inventory, what scripts to run when they're used, a reference to the item when it's in the world on the ground, a reference to the item to hold when it's equipped. All of that could have been broken apart and the game could just have intermediary representations of items. An inventory could just hold an item by name and how many of it we had. Everything else we could need in any other context could be deduced by looking it up in a single data file. Saving and loading could work much in the same way. Rather than preserve every node's state in exactly the way it needed to be, just figure out what data is really necessary for creating a convincing enough illusion that the game is continuing from where you left off. Who's in the scene, who isn't, what's been deleted, what's added, and where. As data becomes less comprehensive and more representational, our overhead becomes a lot simpler and more efficient. You can see how this ostends to what I said earlier about making transitions between areas work in the same way. So, yeah. There's a lot more I could cover about what went wrong in the game. I could spend days poring over every GD script file, every mismanaged node, every line in every function, dissect all the mistakes, and maybe even revel in a few moments of lucidity. But for now, I think what matters most is asking, what do we make of this? Well, I hate to use the term post-mortem. I still love this project. I worked really hard on it for a long time, and I hate the idea of giving up without finishing. I really thought this was gonna be the big game that gets done, wrapped up nice with a bow tie, and sent out into the world. Something I could finally call finished. But the gravity of the situation is that I don't think I can bear to continue on this project any longer. That is, in the state that it exists now. I'm planning to take all the things I've learned and do the unthinkable. I'm I'm gonna rebuild Horse Game 2 from the ground up in Godot 4. Does this mean starting over from scratch? Well, no. See, we still have all the assets, 3D models, animations, textures, sprites, sounds, music, etc. All that still is there. That saves us a huge amount of time. Additionally, we know how stuff should be laid out. We know what we're gonna try and make, so we have the old version to go off of as a blueprint. We just do it better this time, applying all the lessons learned. So the second attempt is going to not only be better, but will be faster, more reliable, and easier to work with. Fewer bugs, fewer problems, and everything beautiful preserved. I'm gonna try to continue working on it regularly again, and while doing so, document the process, creating devlogs and using the process to compare what we fixed to what went wrong the first time. I don't know how long this will take. I don't know what the schedule will look like, or honestly, I don't really know much about anything at all. I'm just a guy that likes making video games. So, if you're interested in the project and want to follow along, please hit subscribe and consider supporting me on Patreon. Additionally, there's a free demo of the old version of Horse Game 2 on my itch that you can check out. If you like this video, hit the like button, leave a comment, let me know what you think, or if you have any feedback, questions, or suggestions. I hope you stick around through this project's lifetime, and be sure to check out my other series on other games I'm working on my channel. Yeah, that pretty much wraps it up. That's all I got. Peace.